All right, the last section of topic 10. This is kind of the second part of 10.5, and it's called secant and tangent segments. It says that if two chords of a circle intersect, the products of the lengths of their segments formed are equal. Okay, and what they mean by that, first of all, it's called secant and tangent segments. If I continued these chords through the circle, if I continued them out here, they would be secants because they would go through the circle and hit that circle twice. So these would be secant segments that we're talking about. But we're just kind of zeroing in on the part that's inside the circle. So when we take these chords, what we're saying is that the product of the two pieces of the chord, so we've got one piece is 3. If I take that times 8, that product, means we're multiplying, is equal to this product. Okay, if we take the second chord here, we take the product of its pieces, we get 4 times x. Those two are going to be equal to each other. So if I solve that, I'd say 24 equals 4x. Divide both sides by 4. So x equals 6. This segment piece right here, this little portion, is 6 units. Okay, that's when the two intersect inside the circle like that. Here's your point of intersection is inside the circle. When that's the case, the product of the two pieces in each chord is going to be congruent. It's going to be equal. Okay, now we got a little bit of a different drawing here. We've got two secant lines here, but now they intersect outside the circle. They're not intersecting inside the circle, they're intersecting outside the circle. And when I do that, we have an equation that says the outside times the whole. Okay, the outside is the portion of the segment that's actually outside the circle. So I would take 9, and I'm going to take it times the whole segment. So from here to here, how long is that whole segment? You'd have to add those two pieces together. So I'd say 20 equals. On the other side, the portion that's outside the circle is the 8, and the portion that's all together. How long is it all together? You could say 8 plus x, or you could say x plus 8. Doesn't matter what order you put that in. Okay, when I go to solve this, I can multiply and say that's 180. 8 times 8. You have to distribute here. Don't forget about distributing. You can't add an 8 and an x. That's not 8x. That's 8 plus x. So we distribute. We get 64 plus 8x. So to solve that, I'm going to subtract 64 from both sides. I'm going to get 116 is equal to 8x. And if I divide 116 by 8, my answer here, you can see, is 14.5. Okay? So we've got, when the intersection point is inside the circle, we're just taking the product of the two pieces. 4 times x is going to be equal to 8 times 3. That's when it's inside. When it's outside the circle like this, okay, it's the product of the outside portion times the total is equal to the outside portion times the total. Okay, and then lastly, maybe a little bit different drawing than the one that you saw up here, but the same scenario because the intersection piece is outside, it's way out here, so I'm going to follow that outside times the whole formula. So the outside of this is 8, and I'm going to take that times the whole thing. So again, that's 8 plus x, and it's going to equal, okay, this is the outside portion is 12, but the whole thing, if I add up those, well, there's nothing to add. It's just 12 times 12. So in that situation where you have a tangent, the outside portion is the same as the whole itself. Okay, to solve this, I'm going to distribute. So I get 64 plus 8x equals 144. Okay, I'm going to subtract 64 from both sides. And I'm going to get 80 equals 8x. So if I divide by 8, x equals 10. Okay, you've got a worksheet you can work on.